Right beneath our feet, in the quiet, dark earth, there's a constant hidden struggle going on for one thing: water. Now, this isn't just about whether the ground is muddy or dusty. We're talking about soil moisture, a secret world that basically dictates the health of our farms, our ecosystems, and yeah, even our climate. So let's dig in. It sounds a little out there, right? But that question, it's the key to just about everything, from growing our food way more efficiently to predicting the next big heat wave. So in this explainer, we're going to learn how to actually listen to the soil. We'll start with just one thirsty plant and then zoom all the way out to see the entire planet. All right, so to really get a handle on soil moisture, we have to start small. I mean, really small. Let's zoom right in and try to see the world from the perspective of a single root tip, where just surviving is this constant, delicate balancing act. It is so easy to think of soil as, well, just dirt, but it's actually this incredibly complex mix of solids, air, and of course, water. And for a plant, soil moisture isn't just about the ground being wet. No, it's about the exact amount of water that's being held in all those tiny little gaps between soil particles. That's the reservoir its roots can actually drink from. A plant's entire life really happens between these two critical points. So on one side, you've got field capacity. That's the sweet spot, the just right Goldilocks zone after a good rain, when the soil is holding the perfect amount of water. But on the other side, you've got the wilting point. Now here's the crazy part. There's still water in the soil, but it's being held so tightly by the particles that the plant's roots just can't pull it out. They're literally dying of thirst in damp soil. That zone in between, that's everything for agriculture. It is the plant's lifeline. Okay, so if you're a farmer, how on earth do you know where your fields fall between those 2 points? I mean, how do you measure something you can't see that's spread out over hundreds of acres? Well, for a very long time, the answer was pretty low-tech and brutal. That's right. The classic method was literally to go out, dig up a sample of soil, weigh it, stick it in an oven to bake all the water out, and then weigh it again. The difference in weight is your water content. And yeah, it's accurate, but think about it. It's incredibly slow, it's a ton of work, you're literally destroying that spot in your field, and you only get one snapshot in time, not exactly a live feed of what's happening. And the contrast with today couldn't be more stark. It's night and day. Today, we have these amazing electronic sensors. You just stick a probe in the ground and boom, you get an immediate, real-time reading. This jump in technology gives us a continuous live feed of the Earth's thirst without having to disturb a thing. But of course, inserting a probe isn't a one-size-fits-all deal. There are a few key technologies, and they each have their pros and cons. You've got the neutron probe, which is kind of the gold standard for accuracy, but it involves radioactive material. So yeah, it's expensive and comes with a whole lot of regulations. Then there are TDR and capacitance sensors. They both work by measuring the soil's electrical properties, which change based on water content. TDR is super accurate and tough, but it can be pricey. Capacitance sensors are way cheaper and simpler, which is great for putting a lot of them out there, but they can be a bit sensitive and need careful setup. It really is that classic balancing act. You're trading off cost, accuracy, and convenience. So getting the data is one thing. That's a huge step. But the real revolution, the true game changer, starts when we use that data to act smarter. This is where we pull the lens back from a single measurement and see how this tech is totally transforming entire farms. Let's look at this really cool case study from Pakistan. Researchers there set up a whole network of these solar-powered IoT sensors across a wheat field. But they didn't just stop there. They did something brilliant. They combined all this on-the-ground data with a bird's-eye view from drones. And this right here is why that combination is so incredibly powerful. The drone map on the left shows you this symptom. You can see those patches of yellow, stressed-out plants. But it doesn't tell you why they're stressed. The map on the right, which comes from the soil sensors, reveals the cause. It turned out that in one spot, a dip in the land was causing water to pool. The soil was actually too wet. The drone saw sick plants, but the soil sensors figured out they were drowning, not thirsty. That's the difference between seeing a symptom and diagnosing the cause. This level of detail lets you take incredibly precise action. I mean, check this out. In a 100-hectare Spanish vineyard, they used sensor data to guide their irrigation. The result? A 25.6% difference in the amount of water they used between the thirstiest and the least thirsty parts of the same vineyard. They were giving water exactly where it was needed and not a single drop more than what was needed. And this is what that data actually looks like to the vineyard manager. You get this sawtooth pattern, which is basically a direct visualization of the vineyard breathing. Those sharp spikes up, that's when they irrigate. And those gradual slopes heading down, that's the vines literally drinking the water day after day. You can see them using it up, and the whole goal is to water again just before they hit that critical refill point. No more guesswork. So we've seen how we can listen to a single plant and then an entire field. Now, for our final jump, we're going to zoom all the way out. We're going to see how this one variable helps us understand the pulse of the entire planet. Because when you add up all those fields and all the forests and all the plains, you get a massive continent-spanning system. And soil moisture is a key character in the story of our global climate, a character that honestly is often forgotten. Think of it like this. When soil is dry, it acts like dark pavement on a hot day. The sun's energy hits it and just radiates back into the air as heat. That's how a warm day turns into a brutal heat wave. But when soil is wet, it's like it has a built-in air conditioner. That same solar energy goes into evaporation, which cools the surface and can even help create more rain. This makes a powerful feedback loop. And because soil moisture changes slowly, it gives the climate system a kind of memory, locking in a drought or wet conditions for weeks. This makes it an absolutely critical piece of the puzzle for getting climate projections right. And this isn't just abstract science. This understanding is now driving real-world global policy. The European Commission, for example, has made soil health a central piece of its environmental strategy, even proposing a soil monitoring law. The whole idea is to make the kind of smart, data-driven farming we saw in that vineyard the new normal, with the ultimate goal of having healthy soils all across the continent by 2050. So, from a microscopic battle for water at a plant's roots to hyper-efficient irrigation on a farm, all the way to the behavior of our planet's climate, we are really just beginning to understand the language of the earth beneath our feet. And as our ability to listen gets better and better, the real question isn't just what we'll learn, but what we'll choose to do with that knowledge.